Hi everyone, my name is Thomas and this is Power Platform Done Quick. Today I'll be showing you something we can do in Power Automate Desktop with variables. Now first off we have custom objects. A custom object is shown here. It's a classic key value storing, and the syntax is quite easy to get down. I made a custom object called credentials, and if I would like to access the values inside the credential object, I'd use the dot notation. The object name and then the key I'd like the value of. So this would get the user value, which is Thomas. You can see if I run it. Yep. But even more so, I can actually, if I want to, add extra objects into my object. So in this use case, I'll have an automation that requires a lot of logins for different systems, system A and system B. And the logins are stored in the sub-objects of sys-A and sys-B, as you can see here. Accessing those is quite easy. It's just the same dot notation, but we have to include the sys-A like this. Next up are data tables. Now, data tables are very useful in almost any automation. Usually we get them from reading an Excel worksheet or website or what have you, but we can actually make them ourselves. So I've used a set variable action to make my own data table. Note that the notation is a bit different from the custom objects. We use square brackets to denote the start and end of a row. So this here would be a data table with 2 rows and 2 columns. If I want to access the single values in the data table, I can use bracket notation again with 2 indexes. So the first one index would be the row index. It's 0 index, so the first row, and then the column index. So this should get me the second value in the first row. Yep. Usually though, we would like to add column header names. We almost always want to do that, so it's easier for others to read our code, and we can do that as well. We use this operator here. I don't know what it's called, but we use this, and Power Automate Desktop will know that the first row here are headers. So I've called them case number and name. And if I run this, you can see that the table is still the same, but now it has headers. And as an extra bonus, I can access the values not with an index, but with a header name. And that's very useful because if you maybe delete a column from your data table at one point, it'll still find the correct value because it's referenced by a name and not an index. Lastly, we can add rows and we can iterate over them. So in order to add rows, it's quite easy. You just use the plus operator and it'll add a row. You can't add a row that's longer or has more columns than the data table already possesses. This is more like a join and not really an add. So keep that in mind. Note that the first value is no longer a string. It is now a float or just a number variable. And I wanted to show you that it's also possible to mix and match different variable types inside the data table. So it's perfectly fine to have a number within a bunch of strings. And here you can see I access that value and add one if I would like to do that. And that's perfectly fine. And in the end, I can use a classic for each loop to iterate over them. And that's really the point of doing all this. If we run it, yep, so you can see I have 4.14, and here are the columns. Thirdly, we have lists. There's already an inbuilt way of creating lists in Power Automate Desktop with the create new list action and add item to list. And you can use that, and it works fine, of course, but it just takes up a lot of space and a lot of actions. I prefer making my lists with a set variable and use these square brackets and enter the values here that I would like. Lastly, but not least, I have here Boolean operators. So most of us who do these automations have come across an if sentence, but usually it's not enough to just check one thing to execute some stack of code. Usually you want to check a bunch of stuff. And you can do that with using multiple if sentences and nest them together. But that's very messy and it just takes up a lot of space and it's harder to read. So I was going to show you the AND operator and how you can do that. So this evaluates a variable, checks its value, and the whole line says if the variable is equal to 1 and equal to 2, this would return true. And so it would say true here equals to true. Of course, that's never possible. It can't be both 1 and 2. So this display message wouldn't come up. But you can put an OR operator in here instead, like this, and we have effectively checked two things at once.